What's going on, PlayDate Community? Welcome back to another episode. My name is Franchovi, and in this series we're building your game. What were we up to? Last episode we were actually turning the enemy into a parent class so that we could have multiple types of enemies. What we want to do in this episode is actually to start adding in the functionality for the second enemy type. So let's get right into it. As you see, we have our crab class here, which is not doing anything. So let's start off by actually creating it and giving it a little animation. We have this enemy to, which I'm going to call it crab table. And then the other one, instead of enemy, I'm going to rename it to jellyfish table. I'm going to go ahead and update my assets. So if you go into the assets.lua, we can add in crab equals open quotes assets / crab, and then we can change the enemy to jellyfish, sorry, with the lowercase j, jellyfish equals assets / jellyfish. Make sure to add some commas in there. Perfect. So those are our assets. So here we can now define the image table. So we're going to say local image table crab equals gfx.imagetable.new, and then we're going to do assets dot crab. There we go. And if you guys want, you can add an assert around that one so that if it returns nil, then the assert throws an error. And actually, funnily enough, the SDK and Lua generally return a second argument, which is the error message if the thing is nil, and assert will conveniently throw that message as the error. So guys, little Lua secret right there. Anyways, image table crab, and we can add a const because we're not going to rename it. And in theory, we can pass in that image table as the second argument to our crab super init function. Oh, sorry, not the image table itself, but the first frame of the image table. So in our init, we're going to do crab.super.init, open brackets self, comma, image table crab, open brackets 1. And that will initialize our crab with an image. Nice. So how do we get our crab on screen? Good news, we have a spawner. So instead of enemy spawner, we're actually going to rename this in main.lua to jellyfish. Let's get it right. Spawner jellyfish. So that's our spawner for jellyfish, as you might have understood from the naming. Then we have spawner crab, which is going to be another spawner. It's going to take in the crab, and then it's going to have crab.spawn rate per tick and difficulty. Now, here's the funny thing, and actually I'm not even sure if this works or not, but we took that spawn rate per tick out of the enemy class and we put it inside the crab class. I just want to test, for the sake of science, if we put the enemy.spawn rate per tick back and we give it a lower value just to make it different, and in the main.lua we leave enemy.spawn rate per tick. No, sorry, my experiment is we don't put enemy.spawn rate per tick, we put crab.spawn rate per tick. I just want to be double sure that it will go ahead and look at that value in the enemy class, which I think it should, if I'm not mistaken, because that's how Lua looks up those things, but I'm not sure, so let's double check. So we have our spawner crab that we've initialized here with the difficulty variable as well. Spawner jellyfish start. So instead of doing spawner, start, we could actually generalize that into just spawners.start, and it would start all spawners. So I'm going to do spawner.start all. Instead of the jellyfish start, I'm going to do spawner.start all. And then I'm going to replace the spawner jellyfish stop with spawner.stop all. So instead of spawner.start, what we want to do is we actually want to call all the instances of spawner and start them all. So we're going to add a function inside spawner called spawner.startAll. It's going to be a static one, so it's going to be a dot. And then we're going to have a function spawner dot stop all, and open close brackets, and then end. And we're going to move these two actually to above the init function right there, because these are going to be our static functions. I'm going to add a comment. Static methods. Sorry, I guess it's a method. If it's class, whatever. And then we're going to say instance methods. Now here's the thing, is that how does the static class, which of course doesn't have a self, how does it know which instances to call? What we're going to do is we're going to create a table that keeps track of the instances. So we're going to do local spawners equals empty brackets, and we can even do const here. So this is going to be our table of instances. So when we do spawner colon init, we're actually going to do table dot insert spawners comma self, and that's at the end of the init function. So by doing this, we're actually adding the instance when the instance is creating. So we don't have a destroy function for the spawner, but if we did, then we could do table.remove self like that. But for now, this is good. What we're going to do is we're going to do inside the start all, we're going to do for underscore comma v in pairs, open brackets, spawners, close brackets, do, and then we're going to do v colon start, open close brackets, and then next line end. That's going to call all the start functions on our spawners, and we're going to copy and paste that into the stop all and replace start with stop. Very easy. So what I'm showing you guys here is actually how do you manage both static functionality and instance functionality. So in some other languages, you might have like actual ways to say like, oh, this is a static method. In Lua, it mostly relies on the dot, even if it's not 100% strict. Like if I wanted to, if I was crazy, I could actually call this spawner function with a colon, except that it would call this one and it would act like there was no self to do anything. Anyways, Lua is super flexible, but in general, this is how you would separate out your static and instance functions. So let's go back to main. We have our spawner.startAll, spawner.stopAll. Our thing is complaining about spawner. He's not identifying anything, so I'm actually going to add the class really quickly. Dash 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 at class spawner above the class, and then I'm going to do spawner equals open close brackets underneath that, right before the class spawner extends. And so if we go back to main, it's not complaining anymore. So in theory, this spawner crab, we don't even need to reference it because it's been created, and we don't need to tell it anything more because we're actually going to start it and stop it using the spawner.startAll, spawner.whatever. Let's double check where is this jellyfish being used, because there's still one instance. And it's the update function. So we could do the same thing with the spawner. We could do spawner.update. And so here's the conflict. If we have a spawner.update without a self, so using a dot, then it's going to call the instance one. And similarly, if we create a spawner.update without a self, it's going to override, like basically you can't have the two with the same name. So either we call one with update all, or we do a tricky thing where we replace this with a dot and we handle the self argument manually. So if we say if not self, then, and here is the static functionality, and then and you do return, and then if the self is defined, then it calls the instance functionality. I hope you can get that. So basically, if you call spawner.update without a self, then it calls the static functionality, which is going to be here. And then if there is a self, then this is going to be ignored and it'll call the normal spawner functionality there. You know what? No. I'm going to keep it simple. Not going to throw you guys under the bus in case it complicates things. So we're going to return that to, we're going to put it back to spawner colon update. And then I'm going to do function spawner colon update all, open close brackets, and then end. And then you guys know what to do. You copy and paste this for loop here, and then you do v:update. Now, if you want to, you can just use this same functionality and put it inside the other update if you want. But let's not lose any more time with that. We're gonna go back to main.lua, and we're gonna do spawner.update all. And you can see that the type checking is actually found that we made an issue there. We put it as a colon when it should be a dot. There we go. Thank you, Lua type checking. And yes, there we go. So now we should be actually updating these spawners. Let's write it. Ooh, image table enemy. What happened there? There's no such thing as an assets.enemy. You see? So let's add the assert there. There was no assert, but it still threw the error, I guess. Assets.jellyfish. And then image table enemy, we can rename that to image table jellyfish. Yoo-hoo! All right, refresh. Uh-oh, self.spawn rate per tick is nil. Okay, so now we know that if you do crab.spawn rate per tick, it's not gonna get the parent one. So I apologize for that, guys. It's not very nice of me to put in broken code on purpose, but we're gonna add a crab spawn rate per tick. We've gotta rename that to crab. So inside crab.lua, you wanna add a line after the class definition saying crab.spawn rate per tick equals 0.001. Let's restart the game. There we go, we have a crab. It's sitting there and not doing anything, and we can fly through it, I believe. Yay, there's 2 crabs. I gotta change the appearance a bit. They're looking a little bit thin compared to the other stuff. I mean, we'll see. Once we start rotating them, maybe it won't look like that anymore. So now that we've got our crab in there, how do we make it move? So this is probably gonna spread out into 2 parts because I don't wanna make a simple enemy. I wanna make a smart enemy. So the way I imagine this is that the crab is actually gonna, first of all, locate the player as usual. It's gonna move slowly towards the player. And then once it reaches a certain distance from the player, it's gonna shoot at the player. That's right, it's gonna shoot at the player. Second thing, if the player loses the human, the crab is gonna run to the player and catch it and actually slow it down. You see? Clever stuff right there. So let's do crab, function crab, update. So we're gonna do crab.super.update. We don't need all that stuff right there. And we're gonna get the target. So local target equals self : get target. Oh, by the way, small mistake I noticed. Inside the class definition, the annotation says crab : playdate.graphics per sprite. We need to change that to enemy. And then inside class extends enemy, not graphics.start_sprite. So now enemy : get target is actually defined. So then we're gonna say if target then, and we're gonna move to target, which I'm getting some brain emptiness. Let me drink some water. I'm gonna go into jellyfish. I'm just gonna copy and paste the move towards player, even if I don't like copy and pasting that. Yeah, I'm just gonna calculate the path to player again, using the same thing. Calculate path to player. And so here we have a speed that we need to define. So we're gonna do local speed movement const equals, and in this case, what are we gonna do, like 1? Let's just make the same speed as we used to have for the jellyfish. And so this is gonna be the X movement and Y movement. And then we're gonna do self : move by X movement, Y movement. As you can see, it's simpler than what the other one was doing. And then there's also gonna be the actual rotation of the mob that we're gonna have to do. So when you're doing self.move by, we also want it to face that direction. So we're gonna do self : set rotation, and we're gonna do angle number, which is clockwise. So I believe we have to convert the angle. So this is gonna be move to player And then the next one is going to be rotate self. So the ship rotates, the jellyfish doesn't rotate, but the crab does rotate. So rotate self, we're going to do local angle degrees equals math.dag angle. And then we're going to do self colon set rotation angle degrees. So that might not be completely aligned in terms of the rotation, but let's test it to see. Yeah, you can see that there's a, oh man, that's looking cool. So we do need to rotate the angle by a little bit, like minus 90. Let's try. Kind of just doing guesswork here. Okay, it's plus 90. And we have the crab that's moving towards the player. How spooky. All right. So what we want to do, so we have this crab that's moving towards the player. Actually, right now it's not doing anything. So in the next 5 minutes or so, I'm going to try to do it. So hold on to your trousers, everybody. So what we're going to do is that if the crab is within a safe distance from the player, it's going to stop moving. It's going to stay where it is. We're not going to add the bullets yet. And then if the player has lost the human, then we're actually going to have the crab grab the player. So move towards the player. So it's going to be some if checking there. So in this case, we know that the target is the player. So this is what we're going to do. We're going to make the move to player based on a condition. So what we want is the distance to the player, which is going to be the distance x squared, y squared, square root of both added together. You know, a squared plus b squared equals c squared. That stuff. All right, if math.square root of, and then we're going to open the brackets inside the brackets, and we're going to say y target minus self.y, and then exit the inner brackets and do little Chinese hat times 2, or sorry, to the power of 2. And then we're going to do x target minus self.x to the power of 2. And so what we're doing there is we're going to do the square root of those two. Sorry, not with a comma, but with a plus. I'm stupid. So change the comma to a plus there. So it's going to be if math.square root, open brackets, y target minus self.y, close brackets, to the power of 2 plus, open brackets, x target minus self.x, close brackets, to the power of 2. So that's going to be the distance from the player to, from the enemy to the player. So we're going to do that like that. Local distance to player equals all of that junk. If distance to player is less than, and then here we're just going to put like what, 30? Then, oh, sorry. If distance to player is greater than 30, then move to player. If not, it's just going to rotate towards the player. So let's see if that works. Refresh. So 30 is a bit small. 100. Let's try. There we go. So now he's moving towards player. And then if you get close enough, he stops. And he just looks at the player. All right, there's a lot of little things that we can do to improve that. But you know what? Let's save that for the next one. You guys are great. Good job for following along. And I will see you in the next episode. Bye-bye.